Hey guys, welcome back. We will be continuing for 11.3 on this, and this will be going into example 2. So when you look at it, where I'm really at is in your notes. I'm on the core concept, and it looks right like this, okay? So choosing appropriate measures. Now, what this means is how do we measure the spread of the data? So what's the best way to, one, represent all of the data with one number? And that goes back to 11.1, mean, median, or mode, okay? And then how do we discuss the spread of the data? So that goes back to 11.1, standard deviation, and then 11.2, where we talked about our 5-number summary. And that's down here, okay? So when you use the mean and standard deviation, that's when you have a symmetric curve. And this will make sense if you remember back to 11.1. If there are no outliers, use the mean. And then the standard deviation goes with mean, okay? Now, if there is an outlier, we don't want to use the mean because one of those numbers is going to throw off the mean. So if you have an outlier, which that's what it means, if you're skewed, you have an outlier. So if you're skewed, now you want to use the median. And medians go with 5-number summaries, okay? Don't forget that. That is really the gist of this. Symmetric, mean, standard deviation. Skewed, median, 5-number summary. And it makes sense if you can connect it back to 11.1. And remember, symmetric means no outlier, so we choose the mean. The same way if you were just given a data set. It's so much easier if you actually understand this part, even if you have to make yourself some flashcards on what to connect what with why. Here, skewed means you have an outlier, which means you want to use the median. Skewed, outlier, median. Okay? And then you just have to remember mean goes with standard deviation, median goes with 5-number summary. Okay? Now, one other thing I want to throw in, you'll learn this when you get later on, but some of you guys like the high level stuff, so I don't want to cheat you out of that. When you look at a symmetric curve, we are looking at what is referred to as a bell curve. You can see that this kind of looks like a bell, okay? And we're going to get into some more information about that. Nothing that's really too relative in Algebra 1, but if some of you guys want to challenge yourself, I suggest looking at bell curves and what standard deviations really mean. We talk about that later in this, and I'll get to that in a little bit. But it's just real interesting how almost everything we do statistically falls back into the bell curve, okay? So now, choosing appropriate measurements. And this is your example 2, okay? So a police officer measures the speeds in miles per hour of 30 motorists. They're also shown in the table on the right, okay? So we have this table. So you see 30 people, and you could just imagine a cop sitting there with his radar gun. Boom, boom, boom. 30 people come by. Here's what he records. Now, how would you interpret the results? If you just looked at these numbers, that's very difficult to make any real meaningful interpretations. But if we can spread this out some, magic way to look at it, i.e. a histogram, well, then we can start to make a lot of references or inferences just looking at the spread of the data. So just to save time, I'm going to use the click through. We already went through how to do this, but maybe I should talk about it a little bit, and I will. Well, I'm sure they'll talk about it here. So we need to make a frequency table. Remember, I told you stay between like 5 and 8. So you need to look at the spread of the data. In other words, you need to look at the minimum to the maximum and then start deciding how you want to break down your data. Your choice may be different than mine. And there's no real wrong choice unless you go by like 1. That would be a problem. But as long as you pick an appropriate interval to keep the number of bars between 5 and 8. Okay? So we look 1, 2, 3, 4, 5, 6. They chose to have 6 groups. And when you look, the minimum up here was 31. I'm looking for it. Well, they have 31 to 35. maybe the minimum is not 31. You could have picked it to go from 30 to 35. So you don't always have to include the minimum. It's just trying to make equal groups. Okay. So the maximum they had was 60. And then they said, okay, if it goes up to 60, the lowest one to me looks like it's 32. But they wanted to just make it broken apart equally. So they decided to go in intervals of 4. So from 31 up to 60, we go in intervals of 4 miles an hour. And then you kind of just do tick marks, okay? So what I'm actually going to do is show you how to do this by hand, because I think this jumps from here to here a little bit quickly, okay? So if you're looking at this data, here's the data we're looking at, and we need to make this into a good frequency. So we went from 32 to 60, okay? 60 minus 32 is, okay, well, that ends up being 28. So I probably would have picked a different interval. I just personally would have. But 28's fine. So they decided to go by 4s, okay? But they just started from 60 and they went down. 60, and then you can see on theirs, 60 minus 4 is 56. So that meant the first range was 56 to 60. And then that means you go down 1, 55. You don't overlap because that would be confusing. What if someone went right at 55 miles an hour? So this was 60 to 56. This one goes down to 55 minus 4 is 51. This goes down to 50 minus 4 is 46. 45 minus 4. And you can see how they went down. Hopefully that makes a little more sense on how you're going to make these. So if you were completely lost before, that should help you make your intervals. And then you just go up and count. How many were between 31 and 35? And now I'm going to go back to the camera, because if you're going to use that, okay, you want to make sure you tick off. So there's 1, and that's it, okay? You see how I went through and I marked that off? Now 36 to 40. 36 to 40. Not seeing any. 1, 2, 3. Did I miss one? Let me see. I believe I'm right. Yeah, 3. And now, let me show you what else I do. So I use those, right? So then I would write my 3 in there. Now I'm going to circle them. So I know I slashed them out and I used them. I would get rid of that circle because that was just my maximum from before, okay? So now I know I've used all those numbers, and now I'm going to go back to my next, and this is getting redundant, so I'm not going to take all the time. But 41 to 45, I would go through, I would slash all the 41s to 45, count those up, put that in my interval chart where you get 5, then I would go back and circle them. This really teaches you how to be meticulous. This is some of the math that you guys need to learn how to do. It's just organizational math. And some of you guys are going to go through this like, well, this is boring. This is busy work. It's not. It's learning how to stay organized. And that is a really good life skill that comes out of your Algebra 1 class that you need to know. Taxes, budgeting, it's going to be a big skill that you need to learn how to know. So while you think this may be busy work, please spend the time and make sure you learn how to do this by hand. Okay. So now that we had our intervals, we could just go right to our chart. And you can see I'm not going to spend all the time because I already showed you how to make one. But between 31 and 35, there was only 1, so you put the little bar at 2. They chose to go by 2s, by the way, because when you look at the frequency, it only goes up to 11. And if you have 6 of these, 2 is fine. That's fine. You can go up by 2s, you go by 3s, you go by 4s, whatever makes it fit in your graph. You just don't want to have your graph too spread out, okay? So now we have our histogram. And what I would do is I would connect the midpoints. And now you can see pretty easily the skew. So because most of the data are on the right, let me actually go back. I'm going to look up here. If we were going to look at this, it would look something like that, right? The tail is to the left. If the tail is to the left, the outliers are on the left. That means most of the data is on the right. If most of the data is on the right, okay, that means most of the people driving by drove 50 to 60 miles an hour. Okay, that's something that we know now. But now let's go back and answer their questions. The data is skewed to the left. So if it's skewed, we choose median. And if we choose median, we choose the 5-number summary. Okay. Using the frequency table and the histogram, you can see that most of the speeds are more than 40. So they said more than 45 miles an hour. I said more than 50. Some of these inferences are choice, but you need to have a really good idea of what it means, because when you take multiple choice questions, what you say might not be exactly what they say, and you might just have to tweak it a little bit to match. So remember, it's not always exact solution. It is best solution. And that takes you through example 2. And that really takes you through pretty much everything you need to know on this. I'm going to continue on because I want to talk about the bell curves. Okay. Everything else you can learn. I still want you to go through all your notes on this. But if you want to cut this off and just listen to what they have to say, that would be fine right now, because I know this is starting to get a little long. But I want to talk about this right here, just because this is good information for you guys to see later on. Okay. So what this is a bell curve. And you can see why they call it that. This is a bell. And this is really cool, because what this does, most of the data in our real lives fit into this. Heights of people, weights of people, intelligence of people, anything you want to see. And this is actually what they use to measure. If you ever heard of grading on a curve, this is what some teachers used to do. I had a teacher in college that did this. So he broke it into categories. And what he did was, I had as many A's as I had F's. I had as many B's as I had D's, and then everyone in the middle was C's. The reason he did that, he would take the mean. He would say, okay, if this is the average on the test, I'm not just grading you guys for how well you do understanding information. I'm making you guys compete. And I had a teacher that did this in one of my hardest classes, because everyone wanted to do well. Not everyone did. Some people failed. And it was a crazy class. I'm not going to lie to you. I don't think it was right, because some kids knew the information, but they just didn't know it as well as other people in that specific class. So I would never do this, but it actually makes sense. So a standard deviation represents how far away from the mean you are. So what he said was, okay, if this is the average grade in the class right here, well, one standard deviation up and one standard deviation down, that's where most of the kids lie. 68% of the kids will fall into that. That's what that means. So 68% of the kids in the class got a C. If you fell between one standard deviation and 2 standard deviations up, you got a B. Okay. And then if you fell between 1 standard deviation and 2 standard deviations down, you got a D. What that means is 95% of the class got between a B and a D. It didn't matter what we got. That's where you fell. And then if you were up here, an outlier, you got an A or you got an F. And what that meant is every test, someone was getting an F. Didn't matter. Didn't matter if you earned enough points to get out of the 60%. So that's what a bell curve is, okay? What a bell curve does is it counts standard deviations. How far away, and they use this X bar. They use a phrase that I don't like, but it's used very often. They call this normal. Normal doesn't mean typical. Normal just means a way to represent a data set with one number. So this would be the normal grade in the class. Let's say someone the normal grade was a 70, okay? To get an A, you could have gotten an 85 if all the data was very close. If the data was spread out, or in other words, you had a bigger standard deviation, well, then that just meant the data was more spread out and the grade systems were different. So you can look this up. This is a really, really interesting topic. And if you have any questions for me and you just want to talk about this, please feel free to get on to our Zoom conferences. I would love to take any questions about this also. But like I said, this isn't really covered on your homework too much. It's just really good topic. And when you're a junior or senior and you want to take prob and stats, this is a great thing to know about. So thank you guys very much. Good luck on your homework, and I will see you on Zoom. For some reason, that didn't turn off. So you're still with me right now.